Okay, so today we're going to be making a graph. The first thing we need to do is make a directory called graph. Then we'll just say JavaScript. CD into there. Okay. We're just going to create a file called graph.js using touch in bash. You can also use git bash if you're on Windows. Now that we have that, we're just going to type code and open up VS Code. Now that we're in VS Code, we're going to do the usual like we have in the previous tutorials, and we're just going to define a test function to allow us to test our data structure while we build it. Console.log tests. Let's go ahead and run node graph. Cool, it works, obviously. And now we're just going to define a class. We'll just say class graph. And this is going to be our graph class. Define the constructor. And this is just going to define three properties. One is going to be vertices, and this is just going to be an empty array. The other is going to be edges, which is also going to be an empty array. So there we go. Let me also add semicolons just to be sort of concise here. And we're just also going to have a number of edges, which is just the number of edges contained in the graph object. Alright, and now we're also going to define add vertex. And this is just going to take a vertex argument. And we're just going to say this, it just goes into vertices and it pushes the vertex to the vertices array. And that's really all that needs to do. And then we're also going to have edges, which, if you're not familiar with the graph, the edges are sort of the connection between the nodes, and the vertices are sort of the nodes themselves. And so this is just going to be this dot edges, and then we're going to create an empty array at the vertex index. It's basically like a key value pair. It's not an array. So just to be clear, this is not an array. It is I guess you could call it an associative array if you'd like. Cool. So we have that. Let's go down. We're going to type remove vertex. This is just also going to take a vertex argument. And then we're going to type, we're just going to find the index of this vertex. So we're going to do that by typing const index. Then we're just going to say this dot vertices dot index of, and then we're just going to say vertex. Okay. And then if you're not familiar with the index of, that actually returns -1 if it does not find the vertex, or basically any object we pass within the array. So with that in mind, we're just going to define an if statement that says if the index is greater than or equal to 0, basically it means the index of has found a literal object within the array. we're just gonna say this dot vertices dot splice index and then one element. And what this does, all this does is it deletes the element at the index. So just deletes the element at the index. Because really what splice does is you can actually replace stuff if you put in the third argument. Like say we put another comma and we had blah blah blah. It would replace it and insert it in that one. But instead this just deletes it because we leave the third argument empty. Okay. Now below this we're going to say while this dot edges, and we're also going to pass the vertex, so we're basically going through the vertex, the array in the edges array. This is an associative array for this particular vertex. This is actually like an array within an array. And we are going to say dot length. Basically, if there is a length, if there are edges for this particular vertex, is what this is saying. So let's just write that out. So while there are edges for this vertex. And now within this while loop, what we're going to do is we're just going to say const. We're going to get the adjacent vertex to this, which this is just going to be the next element in the array. So we're just going to find it by saying getting the array of edges for this particular vertex. And then we're just going to say pop, which pop, what that does is it takes the, I believe it's the last element in the array, and it returns it, and then it also deletes it after it returns the last element. So, yeah. And after that, we're just going to say this dot remove edge, which is another function we're about to define, so just stick with me. We're going to pass it the adjacent vertex and the vertex. So keep in mind that an edge is just the connection between two vertexes. So with that in mind, all we need for the connection to actually be made is to pass the two vertexes. It's not just one vertex. You can't have an edge that adds like node 1 connected to node 1. That doesn't work. It has to be a different node. Or vertex in this case. Some people will call vertexes nodes, just FYI. That's typically what I do, to be totally honest. But anyway. Now we're going to define another function called add edge. And this is going to add an edge in between two particular vertexes. Or vertices is the way to pronounce that. We're just going to say vertex 1 and vertex 2. And then within this, what we're going to do is we're just going to say this dot edges. We're going to say vertex 1 is going to equal. We're actually just going to push it. If we set it equal, that'll erase all the values we already have. So we're going to push vertex 2. So as you can see, this This just adds an edge. And now we're just going to do the reverse for the second sort of expression here. There we go. And once that's all said and done, we'll just say increment the number of edges. So that's the property we stored it in the constructor here. Once that's all said and done, we're just going to remove edge. And one sec. We're also going to take vertex 1. And vertex 2. And we'll just, let's see. We'll define const index 1, and we'll do this by saying this dot edges vertex 1. So for this particular array of edges for vertex 1, let's just say the connections to vertex 1 is the best way to put it. And then we'll say this dot edges vertex 1 dot index of, and then I'm just going to say vertex 2. And if it doesn't find that, then we're just going to return -1. Okay, we're going to do something similar with index 2, just sort of the inverse. We'll just say this dot edges vertex 2. And then vertex 2 index of vertex 1. So we're basically finding the index of vertex 1 within the connections that are stored within the vertex 2 array in the edges property. So once that's all said and done, what we're going to do, let's see, I guess we'll just define an if statement. Then we'll say if index 1 is not, basically if we found something, if it's greater than or equal to -1, if it's in the array, essentially, we're just going to say this dot edges vertex 1, I'll say dot splice, and we'll give it index 1 and 1, which same thing as we did up here in remove vertex, it just deletes it. Okay, and after that's done, since we found the actual property we're looking for, we're also going to decrement number of edges. And there is a reason why we're putting this in the if statement instead of outside of it. This could potentially not find anything. So we want to put this in the if statement so it only decrements it when we actually find something. And we'll say the same thing for index 2. If it's greater than 0. Then we'll say this dot edges vertex 2 and then splice to essentially just delete it. All right. Sweet. And so now we have our add vertex, remove vertex, add edge, remove edge. Let's also define the size function, just to get the size of the entire graph based off vertices. So we'll say we'll return this dot vertices dot length. So that's that. And then we'll also do relations, which are basically the size of the edges. We'll do that by just saying return this dot number of edges. And that's why we stored a separate property for this number, because we couldn't, it would be way more complex to just do it by iterating over all of the edges, because this is sort of an array of associative arrays, or it's an associative array of arrays to be exact. So we'd have to like go through each key in the associative array and then increment all through all of the edges and count them all. It's easier to just keep that. So yeah, let's add one last function. We'll just call it print. And this is just going to print all the functions with, or all of the vertices and edges within our graph. So we'll do this by saying console.log, and then this dot vertices dot app, not app, map. And then it's just going to take the vertex object for each vertice within this array. Okay, so for each vertex in the vertices, we are going to return, then we're just going to type some sort of strings here. We're using I forget what you call these. I guess it's not a tilde. I always forget what you call these. They're not apostrophes. They look like apostrophes, but whatever. So yeah, we're just gonna put within this vertex, and if you use these instead of quotes or apostrophes, you can actually put values within the string by typing a money sign and then mustache brackets. So we're doing that. This is going to print out the value of vertex as a string. Then we're also going to put in between this a string with an arrow. And we'll say print out all the values in the edges for this particular vertex. So we're going to do that by saying this dot edges. We'll say vertex dot join. Basically what we're doing is we're combining all of the vertexes that are in this vertex array for the edges. And we'll say join. We'll just, what should we join them with? I guess just a comma. And that's pretty much it. And then we also, there might be some white space left on the side, so we're just going to do trim. And that's pretty much all we need for that. Since this is map, what we want to do is we want to pass to this object so that we can actually access this dot edges. what this does is it shows you what to set this as, this second argument within the dot map. And so since we passed this as this, it's kind of confusing. We can actually just access this as if we're accessing it within this scope of graph of the object itself. So yeah, after that's all done, we're just going to say dot join just to get the string completely concatenated, and we're just going to separate it by this pipe right here. And then once that's all said and done, we'll just add a semicolon and be done with that. So now we've got the entire graph defined. Let's go ahead and test it. What we'll do is we'll say graph dot, actually, let graph, and we'll just say equals new graph. Okay, and we'll just say graph.add vertex. Let's just call it node 1. And now let's print that just to make sure it's working. So we'll just say graph.print. Okay, let's go over to our command line. You can see we have node 1 in there. Awesome. Let's also do node 2, 3, and 4. Go ahead and define all of those. Okay, let's make sure this works. And we can see we have all the nodes, but there are no edges between them. So now let's try add edge within the graph objects. So graph.add edge. And we're just going to do it between node 1 and node 2 to keep it simple. And as you can see, we've added the vertex to each edge. So this shows you a bit how it works. Node 1 is connected to node 2, and node 2 is connected to node 1. So we can even, let's add another edge to node 1. So now you can see it's separated by commas for the edges. And we have node 1 is connected to node 2 and node 3. Node 2 is connected to node 1, and node 3 is connected to node 1. So, pretty cool, I think. And so now that we have all of that, let's go ahead and test graph.remove vertex. Let's just go ahead and remove, which one should we remove? Let's remove 4. So we'll just say remove vertex node 4. Now as you can see, that worked. So node 4 is deleted. Let's go ahead and clear this, do it again. We no longer have node 4. Awesome. It's just what we want. Let's also say graph.remove edge. Let's test this, and we will, let's just remove node 1 since that has the most nodes. So now after we do remove edge on node 1, this should delete both of these edges, so we'll just have node 2 pointing to nothing and node 3 pointing to nothing. So let's do it. And forget to save the file. Oh. Wait. I can't. That would be if I remove vertices. So let's just remove the edge between node 1 and node 2. Sort of getting mixed up there. So boom. Removed. That's as we want it. The connection between node 2 and node 1 has been removed. So node 2 now points to nothing. And node 1 just points to node 3. Fantastic. So that's pretty much the gist. I'm not going to print size relations. Those are pretty simple. They they definitely work. But yeah, so that's a graph. Thanks for watching.